Let's take a look at sequential correlation, correlating on a sequence of events. In this behavioral profile, we see a correlation based on a sequence of events. It's also a good example of how NerveCenter does smart polling and uses its smart polling capabilities. That is, polling only takes place when necessary, thereby minimizing the impact on the network traffic. In this case, when the alarm transitions to operator status down, no action is taken. NerveCenter polls to determine the administrative status. If it is down, there is no problem. If the administrative status is up, then the specified action is to log data and move on. NerveCenter then polls to determine the interface speed. If the interface speed is less than 56K and it is just used for dial-up, then no additional action is necessary. If the interface speed is greater than 56K, the specified action is to send a beep, email the operator. Next, the NerveCenter polls to determine whether the interface has passed traffic. If the interface has never passed traffic, it may just be coming up, so no action is required. If the interface was previously passed traffic, there probably is a critical problem, and the specified action is to page an operator, open a trouble ticket, or inform the network management platform. The correlation ends with a sequence of events determining the action. Moving on. Trigger functions. We first saw trigger functions in the alarm, the trap mask section. We learned that there were two ways to create triggers when we had a trap come in, either a simple trigger or a trigger function. In a trigger function, we get to interrogate the var binds, the variable bindings attached to the trap, and extract additional information from them. In this particular example, we're looking at the value of the var bind 2, VB2. We're determining if it's a 2 or a 3, and based on which comes back, we fire one or the other trigger. If VB value of 2 is equal to a 2, we fire a trigger that the frame is up. Else, if VB value 2 is equal to a 3, we fire a trigger that the frame's value is down. Now, when we're looking at var binds, there are 4 categories of objects within the var bind that we need to consider: VB number, VB object, VB attribute, and VB value. The VB number returns the number of var binds present in a trap. The VB object returns the sub-object of the var bind looked for, i.e., if we were looking for VB object 6, it would return to us the sub-object of var bind 6. VB attribute returns the attribute of the nth var bind, the var bind that we've asked for. And VB value returns the value of the nth var bind. Let's say, for example, that we received a trap with the following 3 var binds. VB0 is system.sysdescription.0 equals IBMRS 6000. VB1 equals ifentry.iftype.2 equals 6. And VB2 equals if ifentry, if in octets, .3 equals 1, 2, 3, 4, 5. Based on this, we would see these values. VB number would be 3 var binds. VB object 0, the object, sub-object of VB0 would be system.0. The VB attribute of 2 would be if in octets. The VB value of 2 would be 1, 2, 3, 4, 5. The VB object of 1 would be ifentry.2, and the VB object of 2 would be ifentry.3. So why is all of this important? It's important because the true format for a fire trigger is a trigger name followed by a sub-object, followed by a node, and then followed by a delay. So we could, in essence, receive a trap from a node, a Cisco node, let's say. And VB3 could tell us that you're getting interface errors on interface 100. By firing a trigger with a trigger name and the VB object of 3, we would transition to the new state, and we would be focused on the interface, specific interface associated to VB3. In that state, we could then run a poll specific to interface and get additional information as needed. Trigger functions. Action routers. Up until this point, we have taken actions in our transitions, and there have been no conditions. If the action is in the list, it is done, in no particular order except for the clear trigger. Clear trigger always takes precedence. An action router rule gives us the ability to place a condition on taking the action. We write the action router rule, we put them into the action rule list, and in the transition we tell that transition to look at the action router rules. It reads through them, and if it can execute, if it returns true, as you see here, if it returns true based on the conditions of the rule, it will take the action in the rule's action. Could be log to file, send a page, run a Perl subroutine, any of the normal actions that we have. All we're doing is we're allowing ourselves the ability to place a condition on taking the action. The possibilities are that we can take, you can be seen by right-clicking in the rule condition and using the pull-downs to see the different possibilities. Day of week, time of day, alarm, property group, node name, transition state, destination state, and so on. All available to you here. The way the router rule is written is if the condition returns true, it will run the action on the Rule Action tab. Last classes we learned from NerveCenter about doing things in sequence, a sequence of events to correlate. Then we went on and we saw time and how we could correlate things over time. Each of those correlation methods was the use of an alarm's transitions actions, and we created something in that action that helped us do additional pieces. We're going to continue this by looking at alarm counters. And basically we are going to use an alarms transition, the action list, to add a counter and count the number of times we loop through a section of the alarm. And when the count has been reached, we will then fire a trigger, which is a new trigger name that we give it, and we tell it to use that trigger to do something when that counter has been reached. Usually takes us out of a state and moves on to another state and does something else for us. So to count, we have to loop through the transitions or loop through a looping transition. In either way, there are basically two parts to a counter. There is the setup, which is going into the state where we want to count how many times we've been through here. And then there is the increment, which is the looping portion. And once we've done the incrementing, we set the new trigger name and fire that trigger. So we're going to take a look at using that today. It's done by the alarm counter action. It is one of the choices in the alarms transition list of actions. And as I said, there's two parts. And to fill this in, you're going to need to do this in two parts. On the input to the state, you open the action, you click on alarm counter action, and you name the counter. You may want to, at this point, set an initial value at the bottom, where you set the counter value usually to 1 to indicate that at least one of something has happened to start you wanting to count. And then you OK it and you save it to the database. You simply give it a name and you set its initial value. Then in the looping section, whether it's multiple states that loops back to it, or in a looping transition, you open the alarms transition action list, you select alarm counter actions, and you select the name of the counter that you have initialized in the previous step. Then you decide whether you wish to increment or decrement the counter, and you click on it. You type in the name of the new trigger that you wish to fire and the trigger name value, and you select or you enter when the counter equals, and you set a value in here. So in other words, I would select the counter name, I would increment, and I would fire trigger got 5 in 7 when the counter equals 5. I don't have to reset the values or anything. I save it to the database, and then when my behavioral model is in place, all components turned on, masks, polls, alarm definitions, and I get to this point where I initialize the counter going into the state, I will continue to use it in the looping transition, and when it reaches the count that I have defined here, it will fire the trigger name. I go back to my model and I make sure that trigger name takes me out of this state and goes someplace just like the one we used before for the timer. And that's where you set it up. It's in two pieces, the input and the output, the utilization of it, if you will, the incrementing of it. It's done again from the alarm counter action. So let's take a second. I'll open up my NerveCenter. I will open up one of my alarms, and let's say I want to count how many times I go into the logging state and then transition through the loops. To automated actions. NerveCenter has the ability in its actions list to take automated actions for you. Automated actions that are called set attributes. The set attribute action. And the attributes are the functions around the components that we select in the object type field. If I select a node, then the attributes that I can affect are specific to a node. If I select alarm, I can set attributes specific to the alarm. We've seen how to use some of NerveCenter's capabilities to create counters, to create timers, firing triggers with delays to set those timers. We've seen the log to file activity. We've seen things about informs. We've basically done all of this by writing sometimes 1 or 2 trap masks and 1 alarm definition, turning it all on and creating ourselves a behavioral model of small amount of components. Sometimes, however, a single alarm definition isn't going to take care of all of our needs. We may need to, in fact, have 2, 3, or 4 alarm definitions doing things to complete the behavioral model that we have need for, that we have a design for. And what happens there is one of the alarm definitions fires a trigger in a transition with a new trigger name that you give it with a 0 delay so that it fires it instantly. And you go off and you create a second alarm definition using that new trigger, causing a totally separate alarm definition, but controlled by the first alarm. Sometimes that cascades out to 2, 3, and 4 levels of alarms. And that is what we call multi-level behavioral models, where more than one alarm definition is used to create the behavior we need. It's accomplished by doing a fire trigger in an alarms transition with a 0 delay, saving it to the database with our save, 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 and then going back, creating a new alarm definition and using the new trigger we just created to transition, say, off of ground to a new state. When do things like this become necessary is when you have a subordinate situation. The lab today is going to go back and take a look at that high Q, high CPU bottleneck model that we wrote, the one that we modified to become persistent. And the lab is basically saying, I want you to add the ability to count that I've hit 5 bottlenecks inside of a 7-minute period. And to do that, that would be, I believe, this one that I'm showing now. I want to be able to change this so that I can count when I get 5 bottlenecks inside of a 7-minute period. I can probably do it in this alarm definition, but it makes it messy, it makes it complicated, and quite honestly, it's not a key part of this behavior. It's a subordinate behavior. So why not fire a trigger in either of the transitions that create the bottleneck, that go to the bottleneck state? Why not fire a trigger in those transitions with a new name, take that new name and create a new alarm definition that is, in fact, a counter and a timer to count and time just the bottlenecks. So we're just adding to the fact that we can fire a trigger here, the fire trigger action, with a 0 delay, meaning instantaneously fire it for me. Using it, we create a new alarm. And that's all there is to multi-level behavioral models. Using a trigger with a 0 delay to create a new transition in a new alarm and move that alarm along based on other conditions. We're going to be looking at what we call built-in triggers and ICMP basics today. The key here is, right now we've been looking mostly at traps. And traps are a big part of our network and the situations that we have to deal with. The other thing that we've taken only small peeks at are polls, where we actually request information from an agent. What we haven't taken into consideration on any of this is the possibility of network errors. What happens to an SNMP packet when it's sent out to a device and there's no response? How does NerveCenter handle that? What are the possible network error conditions that could be coming back to us? Other than an SNMP timeout, SNMP no such name, there's a whole list of them. And we need to account for those inside the NerveCenter server. The server accounts for them for you, and you don't have to take them into account. And I wanted to point out is that, again, when a network has an error condition, NerveCenter server deals with those for you. It deals with them in the way that it has a set of built-in triggers that it can fire for you in response to a network error condition. The possible built-in triggers, and they begin with something like cannot send, error, ICMP error, etc., network unreachable, node unreachable. There are 3.5 full pages of possible network error conditions that NerveCenter has a built-in response to. Again, the server is programmed to know about these network conditions and responds to them. What we do as NerveCenter administrators is we configure our NerveCenter to know about these responses, how many times we're going to retry, and what we're going to do with the outcome. And that is set here in the administration window on this tab for SNMP. So if you open up the admin utility and you connect to your server IPs and you click on your SNMP tab, you will see that the number of retries is 3, and the retry interval in seconds is 10. Basically what that means is at default, from an installation default, NerveCenter will retry an error 3 times with a 10-second pause between each of the requests. So if I issue an SNMP request and I get an error, I wait 10 seconds. I reissue that SNMP request for the first of 3 retries. The NerveCenter's internal server saves each of these errored responses in a list. It'll save the first error. It'll make its first retry request. When that one gets back with an error, it puts it in its list, and it makes its second retry. Eventually, after the third retry, it will close it out. It will look at the list of 4 entries, and it will try to make some decisions. Decisions like, is there more of one type than another? Did I get 1 SNMP no such name and 3 SNMP timeouts? Whichever it determines there is a more of, it will fire that appropriate trigger. So in the case that I just said where I had 1 no such name and 3 timeouts, it would fire the SNMP timeout error trigger, built-in trigger. How do I know it's built in? Because it's all uppercase. It will fire that on your behalf. It moves along to its next poll and continues on its merry way. The thing here is if there are 2 of each type in this particular situation where I make 1 initial request and 3 retries, I would have a list of 4. And if I had an equal number of errors, then I would take the last set of errors and post those as the built-in trigger. When I make ICMP requests, an ICMP ping response, it follows these same rules. It posts it to an internal list. It makes a set of retries according to these same settings here, 3 retries with a 10-second interval. And it too decides which has more, what type of error has more, and it fires that appropriate trigger for the ICMP responses. So these settings affect both the SNMP and the ICMP retries. When we make these requests and these triggers are built in and get used, they're in our trigger list. We can see them and we can use them. When would I want to use something like this? If I've made an SNMP request and I'm getting SNMP timeouts, I might want to use that SNMP timeout, the trigger that's being fired as a built-in trigger, to start a new model off of ground on SNMP timeout, checking for the SNMP status of this device. That model happens to be already built into NerveCenter. It's one that we can load and take a look at, and it's called SNMP status. We can look at it in our alarm list. SNMP status. If I open it up, and it's a pretty busy alarm. Let's take a closer look. From ground, there is a transition to the error state based on the SNMP timeout. And that would start a new alarm, and it would trigger this off and go to the next state where it would run some things and check. And basically, this alarm goes off and says, hey, if I've had too many SNMP timeouts, or I get an SNMP timeout situation, or an ICMP error situation, I'm going to go to a state and I'm going to run some tests on it, and I'm going to make a decision here in the unknown state as to whether the device is down or just the agent is down. And it's based off of using built-in triggers in response to our normal requests that we just use when they are appropriate to use. When are they appropriate? Not all the time, believe me, because it's such a generic situation that anytime a node let's say you had 3 different models running against a node because of the property group association and all the properties, and it was working. And one of those models happened to take a hiccup and did an SNMP timeout just because of network issues. If you had an SNMP timeout transition in each of those models would move when only the one that had it would have been appropriate. It may take the other 2 to states where you don't want it to be, and it can't complete its check or its decision-making process. So be careful when you use it and where you use it. It can fire multiple locations. It fires it because the node is what's responsible for the error. And if the node already has an alarm transitioned in its name, and there is a state with a pending transition of the same name, it's going to fire it all over the place. So be cautious. Built-in triggers. Let's talk a little bit about this. Let's say I've issued a poll request and it times out. I wait 10 seconds. I issue my first request for retry. It times out. Then my second, it times out. And then my third, it times out. How much time has transitioned? How much time has transpired? If you add all of those 10 seconds up, it adds up to 40 seconds. 40 seconds before that alarm should issue a new poll. If you happened to have your poll running at 30 seconds, then at the 30-second mark, when it's actually issuing a new retry, you would also reissue a new poll. And if it too were getting errors, at its 30-second, it would retry, it would reissue a poll, and you end up clobbering the NerveCenter server with too many poll requests that are initiated before the timeouts are set. So in the case of having 3 retries with 10 seconds, you should not have polls on your server that are less than 40 seconds. You can get into a condition where the server races away. Keep that in mind. Some customers don't like the idea that it decides on an even number of errors. They may change the number of retries down to 2 or up to 4 so that the list contains an odd number of entries. And when the decision process is looked at to decide which there is more of, you have an odd number so that you have at least one way or the other to go. An even number can give you a problem, and it'll only take the last set. Things you might want to look at. The other thing is the interval. If 10 seconds is too long for your local network, why wait 10 seconds? Drop it down to 5 or 6. However, on the other hand, maybe 10 seconds isn't enough because you're waiting for responses that are way far away, and the retries should be out to 12, 15 seconds. These are things that will play into what happens at your network and how it's happening for errors. The typical situation is we do a smart poll. That means we only poll when needed, and if we get the response, we move on. If we get an error, we account for the error by using a built-in trigger in some alarm definition to track it, usually in something like the SNMP status alarm. And we go on our merry way doing what's necessary in the SNMP status. We also have an ICMP status alarm that checks the status of the ICMP components specifically and is controlled by some of the ICMP timeout or other built-in triggers. ICMP timeout is a network error in response to an ICMP ping request. NerveCenter has the ability to issue a ping request via an SNMP packet, and it all gets responded to in ICMP protocol. so that we can go out and we can look at the UDP, the return codes that say network down, node down. We can actually interrogate them and find out what the specifics are. The format of an NerveCenter ping request is to write a poll that says NL ping response. That is the base object and the attribute. If NL ping response is present and the UC type equals 3 and the UC code equals 3, then it's node down, fire trigger node down. Else, if UC type equals a 2 and UC code equals a 3, you can then go to the MIB and figure out all of the possible UC type, UC codes that could be returned and fire an appropriate trigger for each and every one of them. The UC types and UC codes are listed in the NerveCenter.mib file. Quickly, if I open my server, my local Windows server has NerveCenter on it. And if I take and I open the NerveCenter.mib file with a text editor, I can read the NerveCenter.mib file. I can go to search, find, UC type, and it will take me in the MIB down to the NL MIBs ping, NL ping response, NL ping UC type. And those are the possible UC types that is listed here. And as you see below it, there are the UC codes. You can actually get each of these codes back, interrogate your response, and make an appropriate fire trigger. One that might say, if it were an ICMP echo, a 3, an ICMP unreachable, and a 3 means port unreachable. So it's a 3-3. It would be an ICMP port unreachable. It lists them, looks at the list, retries, counts up how many errors of what type, and fires the appropriate built-in trigger in response to the network errors. Let's take a look at an NL ping poll and see if I have one here. Here's one that engineering wrote for us. It lists out a bunch of stuff as to what's happening, and this is actually responding to all the different possible errors. See them in here? That's a very complicated one. Let's take a look at, here's a very simple one. If NL ping response is present, fire the trigger that the node is alive. That's a real simple trigger that says if you get a ping response, fire the trigger that node is alive. What could I do with this triggered node is alive? I could create an alarm definition that loops on ground on the trigger named node alive so that it doesn't go into memory on me. And then I would fire a trigger based on the possible ICMP errors that take me off of ground to different states and tell me that something's wrong. Today we're going to talk about NerveCenter utilities. As a NerveCenter user, you will from time to time run into the need for some utilities to help you along your way. Things from testing a new login to compiling MIBs. All kinds of different utilities, and that's what we're going to talk about today. The first one that we're going to look at is compiling NerveCenter MIB. The basics of compiling a MIB, why you need to do it, and when and how. We have a MIBCOMP utility. The MIBCOMP utility is the old utility. I suggest you don't use it any longer. There is a newer, more convenient, and easier utility called MIBTOOL. But for those who still have older systems prior to 5.0, you would need to use MIBCOMP. And the syntax is to do a MIBCOMP minus trace, minus clean, minus verbose, and use the MIBCOMP.txt file. What is the MIBCOMP.txt file? That is a textual listing of all the MIBs you want to have compiled into the NerveCenter MIB, so that NerveCenter can get its attributes, base objects, and do things. It's arranged in such a way that the older MIBs are structured under V1 things, V2 MIBs are there, V3 stuff is there. It's in order, and not only is it in order of the SMI version, V1 and V2, but when you add a new MIB, at the very beginning of the MIB file is a list of other MIBs, other constraints that need to be included prior to the MIB that you're about to compile into the MIB so that it can make use of them and call them, and those are called the includes. And they have to come before the MIB you're compiling. So you also have to consider that in your ordering. You want to get a new device, and you get a new MIB with it. To compile it, you go to the MIBCOMP.txt file, you make a copy, you add a line to the MIBCOMP.txt file that points to where the new MIB is. That line you add must be in the correct location verse of SMIV1 and SMIV2. It must also be in the correct location for its includes. If it includes or needs something from the SMITC MIB and you put it before the SMITC MIB, you will get a failure. So read the includes, and then you run MIBCOMP minus trace minus clean minus verbose and MIBCOMP.txt. And if you're lucky, in about 3 hours, you'll get a NerveCenter MIB file. Now, the easier way is to be on 5.0 and use the new MIBTOOL utility. The new MIBTOOL utility needs to have Java. It's a Java-based applet. Its available options are -O to create an output file name. The standard or the default is to use NerveCenter.mib. If you happen to be compiling on your production machine and you don't use a new name, you're going to overwrite the NerveCenter.mib file you have, and the next time you start your server, it will read in that NerveCenter.mib file and will hose you because you're not prepared for it. So be cautious here when you do this. Sometimes it's best to make a copy of the entire MIBs directory, put it on another machine, or put it in a different directory structure so it's not in the way of NerveCenter's default directory, and do your compilations and stuff there. And then when you're ready, move over the NerveCenter.mib file, stop the NerveCenter server, restart the NerveCenter server with the new MIB, and let it read everything into memory. There are such options as locations for a repository for additional MIBs to be included, the include MIB name, which would include a specified MIB. You have to use the -MIBCOMP with a file name, and that's because we still use the same MIBCOMP.txt file that we used in the older version. That allows customers to move forward with their MIBs and their structures. They just recompile with the new stuff using the MIBNameMap.txt, the MIBCOMP.txt file. And then there's the -NameMap option, so that if you wanted to generate this on a newer system and make it compatible with a previous 4.1 version, you would do the -NameMap. It generates a file called MIBNameMap.txt, which goes hand in hand with the version of NerveCenter.mib that it just compiled, so that the older systems can run on a newer compiled MIB. You have a strict, which compiles in strict mode, meaning that every single import must be completely accurate and accounted for, and if it's not, you will fail. Now, running it without the strict will give you errors sometimes. Sometimes it will stop. It makes it less important for those imports. It's up to you how you run it. And it also has a -E option to redirect error output to a specified file so that you can look at your error information, figure out what you have to go fix, and make that change to either the text file, the MIBCOMP.txt, or to the actual MIB that you're trying to compile. Depends on what it's telling you. MIBTOOL. The MIBTOOL utility requires a minimum of Java 1.5. As I said, it's a Java-based applet. With 5.1.04 and moving forward, you get both MIBCOMP and MIBTOOL at installation. You get to choose. Soon we will only have MIBTOOL, and that will be the only MIB compilation that we support. You can use the old MIBCOMP.txt file. There is a directory for examples in the MIBs directory for samples that will show you the samples of running this. An example for showing error output files would be to run MIBTOOL minus MIBCOMP, MIBCOMP.txt. That's the text file that tells it all the MIBs that it needs to compile. With a minus strict, you're going to be strict on your includes, and you're going to redirect MIBCOMP1.log and MIBCOMP2.log. MIBCOMP1.log is the input information, and MIBCOMP2.log is the error output information. And you can look at those two files to see what happened, if anything happened. You can review the logs for errors and completion of the information. The last thing I want to mention here before I show you how it works is in reloading the MIBs. Do not try to reload a MIB while the server is running. The reason is that NerveCenter runs off of everything in memory. This is important to know. When you run NC start to start your server, it reads an XML file for the locations, the NerveCenter.xml, for all the locations of where it's going to get things from. And it starts putting all of those pieces into memory. NerveCenter runs on a live in-memory image. The MIB is in there. The database file of all the alarms, all the masks, Perl, subroutines, everything that you've compiled and built are in memory. There's an entire list of the nodes in memory. NerveCenter runs in memory. Serializing the database. When is this necessary? When should you do it? The correct way to migrate between major versions, if you are on version 4, that is major version 4, 4.1.03 is major version 4, minor version 1, patch version 03. If you are on 5.1.03, that is major version 5, minor version 1, patch release 03. Going from 4.1 to 5.1, you should serialize the database out. It creates a particular type of file that is then used to serialize into the next version. It creates an ASC file. Our utilities are built to accommodate release to release between the major versions. When you serialize out on 4.1, we have a schema that knows how to take the information from a 4.1 ASC file, convert it to the appropriate NerveCenter files when you're inputting it into 5.1. There's schemas that help do this. Why do we have schemas? Because there are changes so drastic between 4.1 and 5.1 that the schemas change in the way the databases are structured. For instance, in 4.1 we do not have the ability to color transitions. In 5.1 we can color a transition so that we can mark it as appropriate to what we feel in our alarm displays. To make that change between 4.1 and 5.1, you need to run them through a schema. So you run a serialized DB, serialize the database output operation from 4.1, and you take that resulting ASC file, and you run it into the 5.1 server, and it creates the appropriate files internally. That is the correct way to move between major releases. Between minor releases and patch releases, generally you can just copy the NerveCenter.ncdb, which is the NerveCenter database file, copy the NerveCenter.node file, and restart the server and it'll pick them up. So, between major releases, you must do a serialized DB. To do a serialized DB from the command line with all the appropriate environment and privileges, you need to run serialized DB -F for the fully qualified file.asc name, -O, and you have to tell it whether it is a database to file or a file to database operation. You choose one of the two. And then the DSN if it's a data source for Windows. If not, you put the full path to the appropriate NerveCenter files, the NerveCenter.ncdb file. Let's see if I can see it here and show you. Notice I'm using the man pages. We do have man pages in Linux and in Unix for the NerveCenter utilities that you can refer to. Here is the man pages for the serialized database. The fully qualified name for the .asc, the operation, the -O, whether it's a database to file or file to database. -D, the fully qualified file name path to the NerveCenter database, NCDB. Those are requirements. Options are the -F. That's the same thing. But you can see with the man pages, where am I? I am in the vendor's son. Whoops. CD // database. Yes. This is the NerveCenter database directory. opt OSINC DB. If I look there, I find that I have a NerveCenter.ncdb file. That is my current running version of the NerveCenter database. I have a NerveCenter.node file. That is a textual copy of the nodes that are running currently on NerveCenter. I would want to do a serialized DB pointing at this directory to create an ASC file. And notice we've created some ASC files for you here. We have the NC export of 5.1.asc. We've run it once. We've created a 5.1 output file of the default installation. Serialized DB. Another thing about that is if you wanted to change from a Windows platform to a Unix platform, you would serialize, and that ASC file is available. It can be input on either side, Windows or Unix or Linux, in the ASC format. Otherwise, the databases are not portable between the different platforms. You'll only be doing serialized DB when you go between major releases. NerveCenter has a command line utility where you can go in and manipulate certain pieces of the NerveCenter structure from the command line. The utility is called NCCMD for NerveCenter command. You can get to it from the command line by typing in NCCMD -S space and the name of the server or the IP address of the server, -U space and a user ID, preferably a user who is in the user group for NC admins, -P with the password, and unfortunately, yes, that password is passed in clear text at this time. We are working on that. -N with a port. The port that you need to remember is 32506. 32506 is the command line port, so that would be -N space 32506. And then you can pass it a script file or a set of command line commands, or you can sit there and you can type the commands yourself, or you can build the commands by doing a -? and reading the help that's online for it. What kind of things can you do? The NerveCenter utility has some new features. You have the ability to add a node. Create a new node. Usage. You add node minus N with a node name, minus I with an IP address, minus G with a property group, minus M, yes or no, for managed, S, yes or no, for suppressible, D, yes or no, for deletable, version, V1, 2, or 3 for SNMP version. If you do a version 3, you must provide auth, no auth priv, auth priv, auth priv, all of the possibilities here for V3 encryption. And then you must provide a community string, a read and a write community string. And if it uses a specific port, you can pass it the port number. And to get help for that screen or any screen, you use the minus question mark. So I'm going to show you a little bit about the NerveCenter command line. NCCMD minus S 10.1.2.44. That's the server. A user. Nerve cutter. A password. And then the port, 32506. And it comes back with a NC caret prompt, and I am in a security level for administrator on the server. What possible commands are there? Minus question mark tells me that the NerveCenter command line general help information is to construct a command that is of an action followed by a specific object and then the set of parameters. The actions that are supported are list, set, delete, add, connect, disconnect, resync, and select. Objects supported are alarms, nodes, polls, masks, and server. So if I did something like list node minus question mark, I could find the options that are available to listing a node. The list node would be either minus N with a specific node name or an asterisk, and then the other possibilities are managed, suppressed, property groups, version information. So I could do list node minus N asterisk, and it should list for me all of the nodes, and there it did, that are on this particular server with a name, property group, severity level, whether it's managed, whether it's suppressed, and what its SNMP version is. Minus question mark to be sure. Yep. List is one of them. I can delete a node. I can add a node. Add node minus question mark gives me all the information that we just saw on that slide. The NerveCenter command line. When you're doing things in onesies, twosies, and you want to do an automated action, we have customers who have scripts. They pass the new node information that they want to either add or delete to the script. The script calls NerveCenter command, parses it all together, adds the node, and they have it done almost automatically. They just have to pass the node information to the script. NerveCenter command line. Notice one of the things in its list of supported actions, it doesn't say anything about tracing there, does it? That's because it's one of those commands we have kept to ourselves for a reasonable period of time until we got it all set up so that we could make serious use out of it. So here's this, trace server minus question mark. This gives you what you can do with tracing. I can trace traps. I can dump the pole identifiers. Remember I said how NerveCenter puts all of its poles into memory with an identifier number? I can get that list of poles by dumping the pole identifier list. It puts all of its nodes into memory with a identifier number. I can do a dump node identifiers and see the lists of nodes. It does a one-time read of the current in-memory database and dumps 2 files in the log files directory, which is /opt/osinc/userfiles/logs. That's the default logs directory of dump polIDs.log and dump nodeids.log. And it will give me the information. Along with the polls, it also dumps a list of the triggers that are inside the NerveCenter and their ID numbers. That comes as part of the dumping polls. Okay, let's try this. Trace server dump poll IDs on. We'll dump that list of poll IDs on this machine, okay? Poll identifiers to trace poll IDs.log. This is a one-time one. When you do other tracing, it opens a file and it writes to it every minute the values that it receives. It just says, at this minute, here's what the value is. At this minute, here's the value. It keeps putting them into it. When you do one of these dump poll or dump node IDs, it does it only one time. So let's see if it's over here now. Yep. Not only that, but I have the trace queues that was there. It was not there because this is a buffered write, and the buffer hadn't filled up to this point. Let's take a look at the poll IDs. Get an idea. This particular server has only 5 polls on it, and these are the numbers and these are the names of the polls that it's associated with. But notice those 5 polls incorporate 39 triggers. And here are the lists of triggers. Oh, wait a second. Look at those with the high 2 billion number. See them coming up? Anybody recognize them? They're all uppercase. These are the built-in triggers. These are their numbers. So not only does it give you the triggers that you created, but it gives you those that are associated to a set of built-in triggers. So that is the list of dumping poll IDs. Let's take a look at the traceQueues.log file. It writes all the possible queues. The poll queue, the alarm queue, the log queue. There happen to be 19 of them. Actually 20 if you count 0 as the first one. Nope, there's just 19. There's 19. No, there is 20, ICMP. And this is what gets written to the file every minute. Notice at the top, at the very beginning, it gives you a way to read these columns. The queue, the name, whether it's been initialized, whether it's been enabled, the number of processed, whatever, and the number of waiting. Those are the 2 columns you want to focus on, processed and waiting. If, for instance, I looked at Q1, the poll manager queue, it's been initialized. That's what the true is. The T stands for true. It's been enabled. The T is for true. It's processed, no polls, and it's not backed up. There's nothing waiting. In your server, when you read it live and it's going under heavy load, these numbers will be changing. What you want to watch out for here is that the waiting number does not continue to grow. It returns to 0 or close to 0 and stays down there. If it continues to grow, it means that that particular queue is getting backed up. And there's a reason it's getting backed up, and you need to find that reason. The trap manager queue is the same type of thing. It could be getting back up. Notice I've issued 58 traps, and I have no backups. Okay? So those are the trace queues. Every minute it will write to this file. It's a little difficult to sit there and pick out all 20 of the queues, But if you're having a difficulty, let me know. I have some Perl that we can run against this traceQs.log file, and it will extract separate CSV files for each of the queues for you to look at individually, so that you can look at the trap manager queue by itself and see only those entries for the last however many hours or minutes were in your trace file, just for the trap. And you can that way look down those columns of processed and waiting to see what's happening. So the NerveCenter command line, NCCMD, you would use it to turn on and off tracing. You could use it to add nodes. You could use it to connect servers. You could use it to turn off polls, turn on polls, turn off alarms, turn on alarms. So we could set poll minus question mark, and we could either set a poll, whether it's enabled, suppressed, priority, property, with a poll name, the name of the poll, suppressible, the whole bit. The NerveCenter command line. To get out of it, we type quit, and we're back at the command line. We're going to move on to trap gen. Sometimes you need to be able to generate traps from the command line to NerveCenter to see what's happening, or to simulate a condition to test something. So there is a trap gen utility. The trap gen utility will do V1, V2, or V3 traps depending upon how you construct it. It can use ports if you use a specific port for your trapping other than 162. You can pass it the community string, the destination address of the server, the agent's address, an OID, a generic trap number, a specific trap number, a timestamp, and an entire set of var bindings. An entire set of var bindings. The most simple of trap gens is the first one in this list. Trap gen to the server Blue Ridge. The double quote leaves an empty set of variables from the server Blue Ridge, a 4, a 0, and an empty set of variables. The empty set of variables is for the OID, and the first set of empty set of variables is for the timestamp. What does this do? It actually sends a 4 generic trap. What's a 4? I think that's a link up. How do I know? Well, let's try it. I'm going to do this on a Windows machine. I'm working on a server 192.168.1.0. That's the trap gen. I've already written it in once because I was testing this before. I'm sending a trap from that machine to that machine. What is it saying? Well, there's another utility over here that I can run called trap receive. I'm running it on a second Windows, and it tells me it's waiting for all the incoming traps. I go back here and I send it. Notice that this is actually an authentication failure. It sees it over here. So I can generate a trap, and I can receive a trap. TrapGen operates directly to the SNMP agent without talking to NerveCenter. Trap receive receives directly from the SNMP agent without talking to NerveCenter, so that you can, if there's a question, separate the two and test it. I can do a TrapGen over here and see it coming in over here and know that at least it's getting to the server. It may not be going through my particular mask or my alarm. I can even sit there and have that class alarm running, and if I'm not coming through my mask, I can go over here and turn on trap receive and say, well, at least the brass agent is receiving it, so that must mean my mask is wrong. I did something wrong with my mask or my trigger function in the mask or something. And I can use the trap receive utility to help me test it. Trap gen, trap receive. I can build very, very complicated traps. So trap gen can also be run from inside of NerveCenter as a NerveCenter action. So those are the utilities that I use, that you will use, and eventually become familiar with. The ones we use most frequently are when you feel that you've got a problem with the server, turn on the tracing of the counters and the queues, let it run for a period of time, do it over and over again if you have to, like turn it on every 2 hours for a 20-minute span. So in troubleshooting basics, I use the trap receive quite a bit to make sure traps are coming into my server. Several times people have called to say, I'm not receiving any more traps on this model. And we'll turn on the model and we'll look at it, and sure enough, no traps are coming in. And I will go to a command line, run trap receive, and I will see the trap in particular that they're talking about coming into the brass agent and say, okay, so you've done something wrong. You make a modification. Is it new? Well, I did go in and change my function a little bit, but that shouldn't. You made a change. It stopped working. Let's go fix it. And sometimes it's the simplest thing as VB value. They put a small v and a small b, and it should have been an uppercase V. That's what broke it. Okay? So trap receive is a very good utility to check and use that way. It listens on port 162, and it receives traps as they enter the SNMP agent. You would send traps via trap gen for a host that is receiving trap receive. And it's just simple, trap receive. To get out of it, in Unix, a Control-C. Even in Windows, a Control-C. Okay? You may sometimes try to run trap receive, and it will give you an error. That is probably because the brass agent is not running. Your brass must be running as well as your NerveCenter server. You must have brass D. This is one of the pieces that run. It needs to be there. If you question your server, do a process status grep for brass D. You will see we have a couple of them running here. That's because I have a couple of polars here. The other thing that needs to be there is NC server. OptoSI bin NC server. That tells you at least your servers are still running. The processes are still in the CPU running. If you don't have brass, you don't have the ability to run trap receive or trap gen. You'll get an error for that. Okay, back to troubleshooting. Tracing. Definitely go to the command line and turn on tracing. Go down through it, parse it with the Perl script I have, look at the individual queues or counters, and see what's happening. Why the queues? The queues will tell you what's backing up. The counters will tell you how busy it is. By taking the older minute and subtracting the previous minute, you will see how much of that specific operation was done in a 1-minute period. Why would I want to do that? Well, let's think about this. In the case of traps, if I were tracing counters for traps and I was expecting normal 500 or 600 traps per minute because every line entry is 1 minute apart, and I was doing a difference between the lines and seeing them, and I suddenly got a jump of from 500 or 600 a minute to a several thousand or 70,000 or even 100,000, and then back down to 500, 600, I'd be kind of concerned. I might have something on my network that's suddenly, at some point in time, generating a massive amount of traps to me. It could eventually cause NerveCenter to crash. NerveCenter listens to every single trap on the network. It listens to see if its node is in its list. It listens to see if there is a pending trigger, and it listens to see if it needs to fire that trigger. If not, then it drops the trap. If your normal load is 500 or 600 and you get a shot sometime later in the 70, 80, 100,000 spot, you might want to look at your network and see what's going on. You could be tracing the SNMP counters. And when you differentiate the differences between the SNMPs received, you suddenly see that instead of normally receiving 8 or 10,000 or 12,000 SNMP requests, you get a big spike up to 100, 200,000. Okay, what's happening to cause you to get that big spike in SNMP? So use your tracing. Trace servers, trace counters. We'll parse through them. We'll figure out what's going on. Use the command line to get you to the tracing. Trace server counters on. Trace server queues on. 20 minutes later, go in and say trace servers all off, and it'll turn all the tracing off. Here's that list that I showed you with the minus question mark for tracing. The different possibilities. I can trace specific objects. I can trace traps. I can dump pole identifiers. Trace server dump pole IDs on. To dump node identifiers, trace server dump node IDs on. To check them files, you would check the file trace dump node ID.log. To trace ICMP and SNMP replies and retries, and this is a good one, to see if you're actually executing too many retries on your network, trace server ICMP and SNMP on. Come back and turn it off after a period of time. Server queues is trace server queues on. You could trace OPC messages. You can trace OpenView messages. You can trace fire trigger actions. Alarm counters. If you think you've got an alarm counter that's not working, you can trace the alarm counters. And so on. Okay? We can trace traps. Everything. How to do it again from the command line. You can turn these on from the command line when you start NerveCenter. You can do it with NC start minus and then whichever one you want to turn on. Now, NC server is the binary that gets executed, and you can run that, but I would suggest you run NC start to start NerveCenter and NC stop to stop it. So NC start minus counters minus queues will start the counters and the queues immediately upon startup. And if the server crashes 4 minutes later, it's going to have these files for you. We may be able to see that instantaneously there is way too much expected of the server. But you can start these from the command line. Any of them, minus ICMP, SNMP, minus traps. We can start them right off the bat as NC starts. The types of tracing. Traps, we look at received traps. ICMP and SNMP, we look at the ICMP and SNMP polls that are requested, that are responded to, that are retried, and that are timed out. We can see all of that information. The queues traces the depth of the queues. OPC messages, again, that's an OpenView platform piece. There's an OpenView messages, which is the actual OV platform. There's fire trigger actions. There's counters. We can turn them all on or all off. I don't suggest you turn them all on because they all use the internal log to file thread, and it might start jamming that thread up on you. And then you can check the status of them. Tracing. So if your server has a problem, trace. Turn this on. Get some ideas. You know, if your server doesn't have a problem and you've got the time, go out and get these statistics on a good running server and create yourself a baseline so that you know when you've made a change and something's gone wrong and you trace it, you've got a baseline to compare it to. Baselines are good to have.